Okay, so now we're going to put this into practice. We've got a diagram here that has several vectors drawn on it. And let's take a look. Two of the vectors, v1 and v2, those are drawn as arrows. And then the other vectors, w1 through w4, they're just drawn as points. Now, why are some of them drawn as points and some of them drawn as arrows? Well, try it sometime. If you draw a diagram that has 10 vectors on it and you draw them all as arrows, watch what happens. The picture is going to get very difficult to read very fast. The arrows are going to be overlapping each other. They're going to get tangled up, and there's going to be less room for labeling, and it just becomes harder to read. So that's one of the ways you can decide whether to use point representations or arrow representations of vectors. Just take a look at how many vectors you're going to have to draw. If you're going to have to draw only a couple of vectors, well, then maybe arrows would be helpful. But if you're drawing many vectors, then maybe just sticking with points might help things be a little bit easier to read. Okay, so what are we asked to do? We're asked to add and label some additional vectors. So in part I of part A, we want to first label 5v1, then label 4v2, and then the sum of 5v1 and 4v2. So let's start with the 5v1. And we're going to draw these as points, just for exactly the reason I just said. There's going to be so much added to this diagram. We don't want to draw arrows for every single vector. That it's just going to be too much. So we're just going to stick with points. So how do we approach this? Well, I'm going to draw a green dot for the moment, just at the origin. Think of V1 as a journey, and then V2 as another specific journey. And where that journey takes you depends on where you are when you start the journey. So for example, if I were at the origin and I performed the journey V1 once, that would bring me to this point. If I performed the journey V2 once, that would bring me to this point. Well, what if I performed the journey V1 twice? Well, that would take me here for the first time I performed the journey. Then the second time I performed the journey, it would take me here. If I performed the journey a third time, it would take me here. This is really how you should think of multiples of the vector V1. So this would be V1, 2V1, 3V1, 4V1, and finally 5V1. Oops, like that. So think of it like that. If you're thinking of vectors as points, that's the way you can work this out. So let's label that. That's going to be our 5v1. Okay, let me draw another green dot down here. This can represent us calculating what 4v2 is. So what's the journey of v2? Well, here's 1v2, 2v2, 3v2, and 4v2. And that brings us here. Okay, so I'll turn it blue here just to stay consistent with everything else. And then now we'll go like this, 4v2. Okay, and what about the sum now of 5v1 and 4v2? Well, let's go back to the origin for a moment. Let me draw another green dot that can represent us, that's traveling on a journey. What if I start at the origin and, like, for the moment, let's forget about the 5v1 and 4v2. Let's just think about v1 and v2. If I perform the journey v1 starting from this point at the origin, that's going to take me to here. If I then perform the same journey again, that's going to take me to here. Right? Now, what if I then, starting from that point, perform the journey v2? Well, then that would take me to this point. And then if I perform the journey v2 again, well, that would take me to this point. And then I want to do v1 again, and that could take me here, and so on. So you can play around with it like that. So with that in mind, let's go back to the beginning, look back at what we're asked to compute here. We're asked to figure out where 5v1 plus 4v2 would be on the diagram. Well, why don't we think of it this way? Just perform 5 iterations of v1 as a journey, and then from that point, wherever that leaves you, perform 4 iterations of the journey v2. So we'll go 1, 2, 3, 4, 5 v1, and then 1, 2, 3, 4 v2. And that's how you can think of this when you're labeling vectors as points. This allows you to avoid having to draw diagrams with a whole bunch of arrows and parallelograms and triangles and so on. But anyway, let me label this. So this is 5v1 plus 4v2. Okay, so that takes care of part I of part A. What about the second part? We want to worry about negative 2v1, then 3v2, and then the sum of negative 2v1 and 3v2. So let's start with negative 2v1. I'm going to draw a green dot here to start our journey. So 2v1 would be this, right? That's 2v1, but we're going negative 2v1. So remember, that's going to go in the opposite direction. So negative v1 would take you here, and then do negative v1 again, and that would take you here. So that's really where negative 2v1 takes you. So let's turn that blue, and I'll label that on the diagram. This is negative 2v1. Okay, now what about our 3v2? So 3v2, this is 1v2, 2v2, and then 3v2 here. So I'll turn that blue, and then I'll label 3v2 like that. And then now we want to go negative 2v1 plus 3v2. Okay, well, let's start at the origin again. And we'll say, okay, go negative 2v1, and then go 1, 2, 3 v2. That's going to take you here. So I'll turn that blue, and I'll label it in black finally. So this is going to be negative 2v1 plus 3v2. Okay, so that completes part A. You can see it's getting a bit crowded on this diagram, isn't it? There's an awful lot added to the picture. Let's look at part B, though. We don't, fortunately, we're done adding things to this diagram now. So what about part B? It says to write W1 and W2, W3, and W4 in terms of V1 and V2. So let's start by taking a look at W1. So the idea is, how can you build W1 just from considering some multiples of V1 and V2, and then possibly perhaps adding them together. So let's just start at the origin, and let's figure out how we would get to W1, but only using the two journeys that are available, V1 and V2. So let's do the same thing. Same thing I did before, except this time we know where we're going, and we're trying to figure out how to get there. So let's start at the origin. Let's count how many V1s I would need. So 1, 2, 3, 4, 5, 6, 7, right? You can see where the graph would continue. This is where, as far as I would want to go if I'm adding multiples of the journey V1, because then I can just go 1, 2, 3 instances of V2, and that would take me where I want to go. Okay, so let's just do that again from the start, but do the whole thing. So 1, 2, 3, 4, 5, 6, 7 V1, 1, 2, 3 V2. So that tells you how to do it. So let's there's not much work to be shown here. Let's just work this out down below. Yeah, actually, there's some space down here if you want to use it too, to write some extra notes to yourself. Actually, why don't we do that? So I'll leave this space. You can write whatever you want there. So for part B, we can say that W1 is going to be 7V1 plus 3V2. Is that what it was? Yes. So that's called a linear combination, by the way. We're going to come up to that in a moment. This is an example of we're essentially taking W1 and we're writing it as a linear combination of V1 and V2. We've got some multiple of V1 plus some multiple of V2. Okay, so that takes care of W1. What about W2? Let's take the same approach. Here's W2. We want to start at the origin and get there somehow. So, well, we're not going to take positive multiples of V1 or V2. We're going to have to take negative multiples because we're going in the opposite direction. So let's start this way. 1, 2, 3, 4, 5, 6. So if I go negative 6 V2, that will take me here. And then I'm going to have to go 1, 2, 3 copies of negative V1. So that's how I can get to W2. So let's write that down. So W2 is negative 6 V1 minus 3 V2. Okay, let's figure out W3 now. Where is W3? It's over here. Okay, this one is a little bit different because it's not right on a corner, is it? So we're going to have to be careful here. let's start with the V1. So 1, 2, 3, 4. That's negative 4 V1, right? Because I'm going in the opposite direction of V1, but I'm doing it 4 times. But now for the V2 part, well, I'm going to go, here's negative 1 V2, right? If I start here and I go to here, that's negative 1 V2. But then how do I get from here to here? If I went another copy of negative V2, it would take me all the way to here, but that's too far. So really, if I go back to this point for the moment, what I really want to do is I want to go negative 1.5 V2, or at least that's roughly what it looks like, right? It's just a diagram, so it might not be exact, but that's what it certainly looks like to me. So just from the beginning, we're going to want to go 1, 2, 3, 4. So that's negative 4 V1, and then plus negative 1.5 V2. That's how we're going to get ourselves to W3. So let's jot that down. So W3 is going to be, what was it again? Negative 4 V1 minus 1.5 V2. And if you prefer to write this as fractions, let's say or negative 4 V1 minus 3 halves V2. Okay, so that's the other way you can write it. And then lastly, W4, to finish W4, well, let's start at the origin. What are we going to have to do? Looks like we're going to go 1, 2, but I don't want to go all the way to 3. That's going too far, because you can see W4 is up here. So I want to just go 1, 2.5 V1. And then I'm going to want to go 1, 2, 3, 4, 5.5 V2. So that's the answer. So that's what we want to do. So we're going to go W4 is equal to, so what was it? Again, it was 2.5 V1, 2.5 V1, and I think it was it 5.5? 1, 2, 3, 4. Yeah, 5.5 V4. Or in fractions, this would be 5 halves V1 plus 11 halves V2. Oops, that should be a V2, not a V4. Okay, so that is our, and just to be in the habit here, I'm going to put boxes around these answers. Okay, and I'm actually going to pick, why don't I do this? Include the W1 part, because that's part of the answer. And actually for the W3 and W4, I'm going to pick these ones because actually the fractions are better. It's better to write things in fractions. Okay, decimals are a pain to deal with. So, okay, so that's how you can think about vector arithmetic just from a geometric point of view without having, notice we didn't have access to any of the coordinates of these vectors. We just knew what they were visually in terms of points and arrows.